in the last class, we have started with the folds, right? The entire classification of the folds and their different geometric aspects, right? Now, in today's class, we'll study about the faults. Okay, the new type of structure. Okay, or another type of structure, and very important structure, that will be fault, right? So, what basically fault is? Can anybody define? Is my screen visible?
Yes, sir.
Okay. So we are starting with this term or with this structure which is called fault, right? The fault is a tabular volume of rock consisting of a central slip surface or core formed by intense shearing and a surrounding volume of rock that has been affected by more gentle brittle deformation, spatially and genetically related to a fault. This is more or less the technical definition. Okay, this is more or less technical definition. Now, what fault actually is? Okay, what fault actually is? Say suppose this is the rock mass, right? This is a rock mass which has followed some rupture. Okay, which has some rupture. No, some rupture or some fracture is there. Okay, some fracture is there, and this continuous landmass, okay, or continuous rock mass has been divided into two blocks. Okay, this landmass or this rock mass is divided into two different rock masses or two different blocks, say A and B here. Okay, now due to the brittle forces, okay, here the brittle force is important. Okay, the brittle nature of the rock is important, right? Due to these brittle forces or even the tectonic forces, there may be dislocation of any one of block, okay, any of these blocks, or there might be dislocation of both the blocks, right, relative to each other. Okay, so this block B, okay, this block B has moved in the downward direction, okay, in the downward direction like this. Okay, so such kind of structure forms. Okay, such kind of structure forms. This kind of structure is basically called as fault. Okay, this kind of structure is basically called as fault. So in the simplest way, okay, in the simplest way, faults can be defined as the fracture along which there is a relative moment of blocks, right? A fracture along which there is a relative moment of blocks, the relative moments of two blocks. The moment means it is not isolated movement, right? It is not isolated movement. The movement should be relative to each other. That means when one block is stable or one block is moving, the another block should move more or less, right? Say suppose this block, I am drawing two blocks here. This is one block and this is another block. These two blocks A and B, if these two blocks are there, so B, if B is moving, okay, if B is moving, B should move relative to A, right? B should move relative to A. That means the A should be a reference point. Okay, A should be the reference point, and with respect to A, how much the B, okay, how much B has been displaced. Okay, how much B has been displaced, whether in the downward direction or whether in the upward direction, right? So this basically forms the fault. Okay, now the fault is followed. Okay, the fault or the faulting is basically occurred in the brittle deformational regime. Okay, the brittle regime. Okay, the brittle deformation regime. In the ductile regime, okay, in a ductile regime we have folds. Okay, in the ductile regime we have fold. In the brittle regime will have the faults, right? See, the term fault may also be connected to deformation mechanism, that is brittle or plastic. So see, there should be plastic deformation or brittle deformation. Okay, brittle deformation or plastic deformation. If there is ductile deformation, that ductile deformation refers to formation of the fold. Right. In a very informal sense, the term fault covers both brittle discontinuities and ductile shear zones dominated by plastic deformation. Okay, we'll study about the shear zones. Don't worry. Okay, there is something called as a shear zone where the forces or the shearing forces are highest. Okay, so these ductile shear forces, okay, these ductile shear forces which are dominated by the plastic deformation, they give rise to the faults. Okay, they will give rise to the fault. So this is a very basic idea. Okay, this is a very basic idea about the faults. Right? Now, basically, okay, typically a fault looks like this. Okay, typically a fault looks like this. So these are the beds which have been separated. Okay. Right. So this is actually a fault looks like. Okay, this is actually a fault looks like, or what we call it as a typical fault. Okay, what we call it as a typical fault. So this becomes your block A. This is block A and this is block B. Now here in this case, okay, here in this case, what we can see is that block B is actually sliding down. Okay, block B is actually sliding down. Right, block B is actually sliding down. Right, so this surface, okay, the surface along which the faulting is occurring, okay, the surface along which the faulting is occurring is called as fault plane. Okay, it is called as fault plane. Now these two blocks, okay, these two blocks are basically called as walls. Okay, it is called as wall. Now there are two terminologies, hanging wall and foot wall. Okay, one is the hanging wall, another one is foot wall. Which is hanging wall, which is foot wall? Just kindly tell me, anyone.
जो फॉल्ट प्लेन के ऊपर होती है वो
B
हैंगिंग वॉल होती
A
hanging
and
wall.
B. Just tell me in this term, A and B.
है बी हैंगिंग वॉल
Which is hanging wall and which is foot wall?
बी इज हैंगिंग वॉल ए इज फुट वॉल
B is hanging wall and A is foot wall. Is everybody convinced with this?
Yes, sir.
That B is a hanging wall, but it appears to be going down.
फॉल्ट प्लेन के ऊपर है ना
It appears to be going down. So the terminology of this fault plane, okay, the terminology of this fault plane or the walls relates with respect to the fault plane or the location of these of the walls according to the fault plane, right? Any wall or any block which is which lies above the fault plane. Okay, which lies above the fault plane, right? That will be called as, if say suppose this is the fault plane. Okay, this is the fault plane. Okay, so anything which is above fault plane, that will be hanging wall. Okay, that will be hanging wall, and which is below the below the fault plane will be footwall. Okay, no matter where they lie. Okay, no matter where they lie. So in this case, this is footwall. Okay, footwall, and this is your hanging wall. Okay, footwall and hanging wall, right? Got this? Don't forget this concept of footwall and hanging wall, because there is a classification of faults. Okay, there is a classification of faults with respect to this hanging wall and footwall, or that is the relative position of hanging wall and footwall, right? Okay, so let us first study the Anderson's theory. Okay, first study the Anderson's theory, and then I'll tell you about different types of faults. Right now, according to the stresses, okay, according to the stresses which are present in the Earth, okay, according to stresses in present in into the Earth, Anderson has classified the fault into three basic types. Okay, or three basic uh, stress regimes. Okay, three basic stress regimes. Right. So I have told you in yesterday's class about the stresses. Right. If you remember, sigma 1, sigma 2, sigma 3. What is sigma 1, 2, and 3? Sigma 1 is
Maximum.
maximum stress direction. Sigma 3,
minimum,
minimum. And sigma 2 is
intermediate.
intermediate stress direction. Right. So on the basis of this, okay, on the basis of these three concepts, okay, on the basis of these three concepts, Anderson has given the theory, or he has classified the faults into three different types. Okay, three different types. Okay, on this principle stresses, right? Those are normal faults, strike slip faults, and reverse faults, right? Normal fault, strike slip fault, and reverse fault. What are those? Let us see. Okay, now this is the Anderson's classification. Okay, this is the Anderson's classification, right? Now you can see when there is sigma 1 direction. Okay, sigma 1. So when sigma 1 is maximum, okay, when sigma 1 is when sigma 1 is vertical, right? When sigma 1 is vertical, when sigma 1 is vertical, there will be formation of normal fault. Okay, sigma 1 is vertical, the formation will be of normal fault. Okay, it will form the normal fault, right? When sigma 1, okay, when the sigma 1 is horizontal, okay, when sigma 1 is horizontal, it will form strike slip fault. Okay, it will fall from the strike slip fault, right? And when sigma 1, okay, sigma 1 appears in sigma 1 appears in this perpendicular to this sigma 3, okay, in different direction, so that will be called thrust fault, or it will be also be called reverse fault. Okay, it will also be called as the reverse fault. Okay, got this? So this is the Anderson's theory. Okay, this is the Anderson's theory, or this is the Anderson classification. Okay, this is the Anderson classification. So according to the Anderson classification, we have three types of faults. Okay, three types of faults: normal fault, reverse fault, or thrust fault, or strike slip fault, right? So on the basis of this, we have defined all these three types of faults. Okay, three types of faults, right? Okay, so before going any further, let me quickly tell you. Okay, let me quickly tell you about the anatomy of the faults. Okay, and some of the important concepts which are useful for you, right? Or geometry of the faults. So non-vertical faults separate the hanging wall from the underlying footwall. The hanging wall is lowered relative to the footwall, right? Hanging wall is lowered or down thrown when with respect to footwall. The fault is called as normal fault. Okay, the fault is called as normal fault. So what is the case of normal fault? Normal fault is the fault in which the hanging wall, okay, hanging wall goes down. That means the down throw is of the hanging wall, right? The down throw is of the hanging wall, or the lowering of the block is of the hanging wall, right? So this is your normal fault. Okay, this is your normal fault when the hanging wall going down. Okay, now hanging wall goes down. Now it is not like hanging wall is going down. There are endless possibilities. Okay, there are endless possibilities. It might be it might have the hanging wall which is steady. Okay, hanging wall which is steady and the footwall has moved up. This may be possible. Okay, this may be possible. Or both the walls both the walls have gone down, but the hanging wall is gone more downwards. Okay, so these possibilities are present. Okay, these kind of possibilities are present. Okay, so there are endless possibilities present. Okay, endless possibilities present, but the basic factor remains the same, right? The basic factors remains the same is and the basic factor is that the foot wall, okay, the foot wall and hanging wall, okay, the foot wall and hanging wall should have this relationship in which the hanging wall is down thrown and foot wall is upwards. Okay, right? Now the opposite case, in opposite case, what will happen? The hanging wall will up thrown. Okay, the hanging wall will be up thrown. Okay, hanging wall is up thrown relative to the foot wall. Again, relative movement is very much important here. What is relative here for us? These are the blocks. Okay, these are the blocks. So these two are, if these two are the blocks, this is hanging wall, this is foot wall, and the hanging wall is going up thrown. Okay, the hanging wall is going up thrown. Okay, and this will be called as reverse fault. Okay, this will be called as the reverse fault, right? Now if these faults, okay, if these faults, there is no relative movement like this. Okay, there is no relative movement like this, but the movement is lateral. Okay, the movement is lateral, that means sideways. Okay, the movement is sideways, right? These kind of faults are called as strike slip fault. Okay, strike slip fault because they follow the strike of the bed. Okay, or they follow the strike of that entire geographic, or that entire this rock mass. Okay, so that will be called as strike slip fault, right? Now this strike slip faults, okay, strike slip faults can be sinistral. Okay, can be sinistral, that means be left lateral. Okay, that can be left lateral, or dextral, that is the right lateral. Means the block might have moved leftwards, or block might have moved rightwards. Okay, now with a strike slip fault typically occurring as a steep fault and reverse fault commonly having lower dip than normal faults, the full range is available. Okay, if the dip angle is less than 30 degree. Okay, now this is important. If the dip angle is less than 30 degree, the fault is called low angle fault. Okay, the fault will be called as low angle fault. While the steep faults dip steeper, okay, the steep faults dip steeper, and their angles, okay, their angles are 60 or more than 60 degree. Okay, the angle is more than 60 degree. Okay, now the low angle thrust faults, the low angle reverse faults basically. Okay, the low angle reverse faults, they are called as thrust faults. Okay. The low angle reverse faults are called as thrust faults, right? They move for, or they have larger extents. Okay, they have larger extents, and they are having the extent of thousands of kilometers, and majority or major faults or larger faults in the world are basically the thrust faults. Okay, they are basically thrust faults, right? Some of the larger faults, just like the faults in Himalaya, MBT or main central thrust, okay, main boundary thrust, okay, main frontal thrust, right? These faults, these are the larger faults, and all these faults are basically thrust faults. Okay, these are basically the thrust faults. Okay. Now you can see in this diagram, okay, in this diagram that these are given. Okay, this is the foot wall, this is hanging wall. Hanging wall is going downwards. Okay, hanging wall is going downwards, so hence this is normal fault. Okay, this is a normal fault, right? Now normal fault is basically or normal fault shows extension. Okay, the normal fault shows extension, right? Extension of the crust. Okay, normal, wherever there is a normal fault, there is extension of the crust. Okay, it will show the extension of the crust. When there is strike slip fault, there is, the area is conserved, there is no extension, no compression. Okay, there is no extension, no compression. And in case of reverse fault or thrust fault, okay, reverse fault or thrust fault, this will show compaction, okay, or compression. Okay, so with normal fault you will see extension. Okay, with normal fault you will see extension. With reverse fault you will see compression. Okay, with reverse fault you will see the compression, right? So this is in the first diagram, it is normal fault. Okay, it is the normal fault. Then in the B diagram B, it is strike slip fault. Okay, it is a strike slip fault. Okay, you can see here. There's this block. These two blocks are moving. Okay, these two blocks are moving relative to each other along the strike direction. Okay, along the strike direction. And this is the in the diagram C. It is reverse fault. Okay, this is basically a reverse fault, or if its angle is less than 45 degrees. Okay, if the angle is less than 45 degrees, then it will be called as thrust. Okay, it will be called as thrust or thrust faults. Okay, it will be called as the thrust or the thrust fault, right? So this is the basic terminology which is used. Okay, this is the basic terminology which is used for defining the faults. Okay, now sometimes there is the fault. There is a fault which has a curved type of fault plane. Okay, which has a curved fault plane. Okay, these fault planes are these kind of faults are called as the listric fault. Okay, these kind of faults are called as listric fault. Okay, this will be called as listric fault. It has a curved fault plane. Okay, it has a curved fault plane, right? So the fault that flattens downward. Okay, fault that flattens downward. So whenever it is going downwards, it got flattened. Okay, it will be called as listric fault. While downward steepening faults are called as anti-listric, the opposite case of the listric fault. Okay, as opposite case as that of the listric fault, right? So this will be called as least trick. Remember the curvature of the fault plane. Okay, remember the curvature of the fault plane. Right, if the curvature is there, it will be called as least trick. Right. Now, the structures which are related, okay, the structures which are related with respect to this normal fault and reverse fault, okay, this normal and reverse fault, or basically the normal faults, not reverse faults, okay. So if two separate normal faults, okay, two separate normal faults dipping towards each other create a down thrown block, okay, two separate normal faults which dip towards each other, okay, dips towards each other, they create a down thrown block, okay, they create a down thrown block, and this block is known as graben, okay, this block is known as graben, or this structure is known as the graben. That means the depression which is formed by two normal faults, okay, a depression which is fault formed by the two normal faults in which the central block, okay, the central block has been down thrown, okay, the central block has been down thrown, and this down thrown block has created a valley like structure, okay, a valley like structure, and that valley like structure will be called as a graben. Okay, now you know the famous grabens in India, right? You know very well famous grabens in India, just like the Godavari graben, right? The Godavari graben, Pranhita, right? Mahanadi graben, there are these grabens, okay, so these rivers flow through the grabens, okay, the rivers flow through the grabens, okay. Now normal faults, they which dip away from each other, okay, normal faults which dip away from each other, they create upthrown block, okay, they create a central block which is upthrown, okay, the central block will be upthrown, okay, and this upthrown block, this kind of structure will be called as the host, okay, this kind of structure will be called as host. That means the central block has been uplifted, okay, the central block has been uplifted, okay. So in such cases when these for this host and graben structures are there, the largest fault in that area will be called as the master fault, okay, the largest fault in the area will be called as the master faults, okay, and then there are some minor faults, okay, some of the minor faults, and these minor faults are known as antithetic or synthetic, okay, antithetic or synthetic, okay. So the antithetic faults dip towards the master fault, right? Antithetic fault dip towards the master fault, while synthetic fault dips in the same direction as that of the master faults, right? So these are the types, okay, these are the structures which are found with respect to the faults or the normal faults. Now see all these structures into the diagrams, okay, all these structures into the diagrams. Now see here, this is the host, okay, this is the host, this is the central block which has been uplifted, okay, a central block which has been uplifted or upthrown. These are the two normal faults, okay, these are the two normal faults. See, this is fault A, this is fault B, okay, and fault A and B, they two are making or these two blocks, they are dipping away from each other, okay, they are dipping away from each other, right? And these, when they are dipping away from each other, okay, when they are dipping away from each other, they have uplifted a block here, okay, they have uplifted the block, and this uplifted block is called as the host, okay, this uplifted block is called as the host. Faults basically are exceptional traps for petroleum, okay, exceptional traps for the petroleum. You might be knowing about this Bombay High, correct? You might be knowing about this Bombay High.
Yes, sir.
माहिती आहे की नाही बॉम्बे हाय? What is Bombay High?
Yes, sir. माहिती आहे.
माहिती आहे ना? So why Bombay High is called Bombay High? Why not Bombay Low, or why not Bombay Plain? Why high? Because the Bombay High oil field, okay, the Bombay High oil field lies within the host, okay, it lies within the host. There are many structures basically. There are many structures. There is basically a doubly plunging anticline. Okay, there is a doubly plunging anticline in this Bombay High area. Okay, that spreads for the entire Surat to Ratnagiri coast. Okay, right from Surat to Ratnagiri, that entire coast is there. Okay, and that entire coast hosts the petroleum. Okay, so it has a doubly plunging anticline, and inside the doubling plunging anticline, this oil field has the faulted terrain. Okay, it has the faulted terrain, and that faulted terrain is a host, and it has acquired the almost entire petroleum which is produced in India, right? Because oil these Bombay High oil field produces almost 60% of India's total domestic production. Okay, almost India's total domestic production, the 60%. So it is the largest field in India. Okay, the Bombay High is the largest oil field in India, which produces this much amount of crude oil daily, right? So host structure or the faults altogether, okay, faults altogether, they are excellent traps for petroleum. Okay, they are excellent traps for the petroleum, right? Now see these grabens. Okay, now see the grabens. Now what this graben is all about, in which the two faults, okay, the two faults are dipping towards each other. Okay, two faults are dipping towards each other, so that they are making these central block to go downwards. Okay, to the central block going downwards. Okay, so they are forming the graben, or they are forming the depression, and that depression will be called as graben, through which the rivers can flow. Okay, through which the rivers can flow, right? Now there is something which is called as half graben. Okay, the half graben structure. Half graben means it is bounded from one side only with the normal fault, and another side is not that well defined. Right, now here what you have to identify is this main fault or the master fault. Okay, what you have to identify is the master fault. This is the master fault or the main fault. Now here there are two types of minor faults. One is synthetic, another one is antithetic. Okay, the synthetic fault and the antithetic fault. Now the synthetic fault dips in the same direction as that of the master fault, so they are basically parallel, not exactly parallel. Okay, not exactly parallel, but they show equal or similar amount of dip direction. Okay, similar amount of dip direction, that means this direction and this direction will be similar, right? So such fault will be called as synthetic fault. Okay, such fault will be called as a synthetic fault. In case these fault, the minor fault which dips away from or which dips towards the master fault. Okay, it is dipping towards the master fault, right? So if you extrapolate these, they will somewhere join. Okay, if you extrapolate this, they will join somewhere. Okay, so these kind of faults will be called as antithetic fault. Okay, these kind of faults are called as antithetic faults, right? Clear this concept, synthetic and antithetic. Okay, this is the synthetic and antithetic faults, right? Now these are the very important concepts, the slip separation, okay, displacement, all these things. Okay, the dip, displacement, slip, and separation. Okay, these are very important concepts while we are talking about the faults. Now the vector connecting two points that were connected prior to faulting indicates the local displacement vector or net slip direction. Okay, net slip direction, that means two points were once joined. Okay, this say this is a zone, right? This is a zone in which these two points here in this entire zone, any two point, take any two point. Okay, they were once joined. Now there was faulting. Okay, there was faulting. Now after faulting, what happened? The 2 points got separated, right? 2 points got separated. This separation, okay, this separation shows the displacement. Okay, this shows the displacement, and the vector, okay, vector which connects to these 2 points, okay, vector which connects to these 2 points will be called as displacement vector. Okay, this will be called as displacement vector or net slip direction. Okay, it will be called as net slip direction, right? Now, ideally, a strike slip fault has a horizontal slip direction. Okay, the strike slip fault has a horizontal slip direction because it is horizontal fault, right? It is the horizontal fault, and hence it will have the horizontal slip direction. Okay, and normal and reverse fault have the displacement vectors in the dip direction wherever they are dipping. Okay, in whichever direction they are dipping, the dips they are the vertical the displacement vectors. Okay, the displacement vectors should be in the dip direction, right? It should be in the dip direction, right? Whereas individual slip events may have had different slip directions, right? Now you have some diagrams here. Closely observe these diagrams. Okay, here, okay, here you can see this is the fault plane. Okay, this is the fault plane along which there has been faulting. Okay, along which there has been faulting. Now this line, okay, this line represents the displacement vector. Okay, this line represents the displacement vector. Now on the fault plane, what we have is is something called as striations. Okay, it's something which is called as the striations. What striations actually is, when there is rubbing, okay, when there is rubbing of the two blocks, when they are moving, like these blocks are moving, so when they will move, okay, when they will move, they will have rubbing here, friction. Okay, they will have the friction, and due to this friction, okay, due to this friction, the striations will be formed. Okay, striations will be formed, and these striations will be called as slicken sides. Okay, these striations will be called as the slicken sides. Now, taking the angle between the striations, okay, the striations or the slicken side with respect to horizontal, okay, with respect to horizontal, that will be your pitch. Okay, that will be your pitch or rake. Okay, either it will be called as pitch or it will be called as rake. Okay, now in this diagram you can identify some of the terms. This is dip separation, means separation in the direction of the dip. Okay, the horizontal component of separation, okay, horizontal component of separation is called as heave. Okay, this will be horizontal separation. Okay, this will be horizontal separation or horizontal component of separation, and this throw is vertical separation. Okay, the vertical separation, that means horizontally, okay, horizontally, for what for what distance the 2 points have these 2 points have traveled. Okay, these 2 points have traveled, that is horizontal separation. And vertically how much the distance has gone, that will be called as its throw. Okay, that is called as its throw. We have used these terms, down throw, up throw, right? What is down throw, what is up throw, right? Down throw means if it is going downwards, it will be called down throw. If it is going upwards, it will be called up throw, right? Heave is this horizontal separation. Okay, he will be its horizontal separation or horizontal component of separation, right? The horizontal component of separation. Right. This is all is given. Whatever I've told you so far is written in all these long paragraphs. Okay, they're written in these paragraphs. You can read it when I'll upload these notes. Okay. Are you guys having some problem with notes or videos in the app?
No, sir.
Do you have any problems? Because some I've received some calls or message that these videos are not visible or notes are not visible. कोणाला आहे का काही प्रॉब्लेम असा की नोट्स दिसत नाही, व्हिडिओ दिसत नाहीये?
सर व्हिडिओ दिसतो पण एकदम असं फुल स्क्रीन नाही होत, असा थोडा वरच्या विंडोमध्ये चालतो.
Notes need. What exactly you need, Bhavan? तो व्हिडिओ जो दिसतो ना तो कमी याच्यावर, तो ऍक्च्युली तो ऍपचा प्रॉब्लेम आहे.
अच्छा अच्छा, ठीक आहे ठीक आहे.
वी कॅन नॉट डू एनिथिंग टू दिस. तो
नाही
दॅट
तसं
इज
काही
द प्रॉब्लेम
प्रॉब्लेम
विथ
नाही,
अल्गोरिदम.
सगळं दिसून तर जाते सगळं.
हो, त्याला थोडासा दोनदा टॅप करायचा म्हणजे थोडासा मोठा एक्सपांड होतो, झूम होतो.
हां हां हां, ठीक आहे.
फुल स्क्रीन प्रॉब्लेम आहे, तो आहे तो. दॅट इज द प्रॉब्लेम विथ अल्गोरिदम. वी कॅन नॉट डू एनिथिंग टू दॅट. You can if you want to enlarge that picture, you can tap on the screen twice. Okay, fast, just like you like any photo on Instagram. Okay, tap on that video twice, so it will enlarge a bit. Okay, so आता जो 60% कव्हर करतोय, थोडासा 75% पर्यंत कव्हर करेल. राईट. कधी कधी कारण मला असं वाटतं की काही लोकांना प्रॉब्लेम येत आहे की व्हिडिओ दिसत नाहीये किंवा नोट्स दिसत नाहीयेत. असं काही असेल
नोट्स
तर
नव्हते दिसत आधी, मग मी अमित सरांना विचारलं होतं तर मग दिसले मला नंतर.
अच्छा, असेल काही प्रॉब्लेम. तो कनेक्टिव्हिटी मध्ये कधी कधी प्रॉब्लेम असतो. ओके, दॅट इज अ मायनर प्रॉब्लेम. चलो नेक्स्ट. Now this is the entire classification. Okay, this is the entire classification of faults on the basis of their dip dip slip. Okay, or that amount of slip, amount of uh, movement. Okay, the amount of movement, right? As yesterday we have taken the triangular diagram in which I've told you about the axis. Okay, axial plane, the tilt of axial plane. On the basis of tilt of axial planes, the folds were defined. Okay, or the folds were classified. Now the on the basis of its movement, okay, its movement, it will have this classification. Okay, the first, it will be dip slip faults. Okay, the dip slip fault. Now dip slip fault covers reverse fault as well as normal fault, right? Don't consider that dip slip fault is only normal fault, because this is the misconception of many people. Right, this is the misconception of many people, that dip slip faults cover only normal faults. No, deep sleep fault covers normal fault as well as reverse fault, because both the faults, both the types of faults, they are dipping or they are moving with respect to the deep direction. Okay, with respect to the dip direction, right? So these are all the dip slip faults. Okay, these are all the dip slip faults, right? Here it is horizontal. Okay, it is horizontal where the separation is along 90 degree. Okay, here some angle is there. Okay, it is again steep fault, it is more steeper fault, and this basically is a vertical fault. Okay, this basically is a vertical fault. Now there is again a problem with respect to the vertical fault. Okay, there is a problem with respect to vertical fault. What is the problem? The problem is that you cannot identify. Okay, you cannot identify, or it is very much difficult to identify the walls. Okay, this is very much difficult to identify the walls. Which wall, okay, which wall is hanging wall and which wall is the foot wall. Okay, which is the hanging wall and which is the foot wall. It is very very difficult to identify, right? So these are the dip slip fault. This basically is a vertical fault. Okay, now here on the basis of pitch, the horizontal faults are there. Okay, horizontal faults, that means they are along the um, along horizontal plane. Okay, along the horizontal plane, right? If the pitch is 60 degree, it will look like this. Pitch is 30 degree, right? So there are different faults. Now again, these are the vertical faults, different types of vertical faults, right? Now here, dip slip dominated fault. Okay, these are the dip slip dominated fault, properly dip slip fault or the dip fault, right? These are the strike slip dominated fault where the strike is they are going towards the strike. Okay, so the horizontal fault, okay, the this strike slip dominated fault of dominant is the strike slip, and here all these are the strike slip faults. Okay, these are the strike slip fault which move along the strike of the bed or strike of the area, right? Strike of the bed or strike of the area. So this is the basic classification. Okay, this is the basic classification which is based on its uh, dip, okay, or its movement. Okay, its movement. Understood so far?
Yes, sir.
Next, next is this thrust faults. Okay, which is again an important point. Okay, this is the important point. The thrust faults. Okay. Now, what is this thrust fault? Thrust fault basically is the low angle reverse fault. Okay. Low angle reverse faults. Okay. These are the low angle reverse faults, right? Angle should be less than 45 degrees. The angle should be less than 45 degrees. See, the low angle reverse fault or low angle fault or shear zone where the hanging wall has been transported over the footwall. Okay. The hanging wall has been transported over the footwall. That means footwall and hanging like this, right? Now the movement should be predominantly deep sleep. I have told you just now. Okay, I have told you just now that reverse faults are also the deep sleep fault. Okay, reverse faults are also the deep sleep faults. Okay, thrust separates substrate from an overlying thrust nappe. Okay, there is something called as nappe structure. Okay, you might have heard this nappe structures. Okay, when this entire zone, okay, this entire zone gets thrusted up. Okay, the entire zone gets thrusted up, and it separates the substrate from the overlying thrust. Okay, the thrust nappes are characteristic feature of contractional orogens such as the Caledonian, Appalachian orogens, and the Alps. Okay, so in these mountains, in this kind of mountains, you will find many of these nappes. Okay, or the thrust nappes. Even in the Himalayas, okay, even in Himalayas, you will find numerous amount of these nappes. Okay, so nappes exposed at the surface can be discontinuous. Nappes exposed on the surface can be discontinuous because erosion has selectively removed some of parts while others have spared. Okay. So when the nappes, okay, when the nappes get eroded, okay, when the nappes get eroded, the erosional remnant, okay, the erosional remnant which is left behind, okay, which is left behind is called as a clippe. Okay, that structure is called as a clippe. Clippe is nothing but the erosional remnant of the nappe structure. Okay, erosional remnant of the nappe structure, right? So it is basically a German word. Okay? This is basically a German word which is also called as outlier. Okay. Similarly, there is something called as erosional hole. Okay, this erosional hole through a nappe that exposes the underlying rock unit. Okay, exposes the underlying rock unit or the nappe. Okay, such as those seen on the map of the Scandinavian Caledonians, which is called a fenster, German word, or a window. Okay, I'll show you this all this in the diagram. so that it will be better understood by you, right? This is the structures, or these are the structures, right? You can see here, this is the nappe structure. Okay, this is the nappe structure. This is faulted zone. Okay, this is the faulted zone, or this is the fault, right? And this fault is getting or this fault is a thrust fault. Okay, this is a thrust fault, and this thrust fault, okay, this thrust fault, essentially it is folding this area. Okay, essentially it is folding this area, and this area will come on the surface. Okay, it will come on the surface like this. Okay, come on the surface like this, and it will form a nappe structure. Okay, it will form a nappe structure, right? These nappes, okay, these kind of faults, these nappe structures when get eroded, okay, these kind of structures, they when they get eroded, it will be called as a clippe. Okay, it will be called as a clippe structure. Okay, if continued erosion is there, it will form a window. Okay, it will form a window which will expose, okay, which will expose the rocks which are present inside. Okay, it will expose the rocks which are present inside that zone. Okay, inside that zone, or inside that formation, inside the fault basically. Okay, got this? So this is about the thrust faults. Okay, and then strike slip faults. Okay, then the strike slip faults. Now what are the strike slip faults? Strike slip faults when there is a displacement vector is parallel to the strike of the fault and thus parallel to the surface of the earth. Okay, these are parallel to the surface of the earth, right? I have told you this. The strike slip fault can be sinistral, left lateral, or dextral, right lateral, and involves no vertical movement of the rocks. So there is no vertical movement, right? There is no vertical movement, but entire movement is in the lateral direction. Okay, it is in the lateral direction or in the horizontal direction, right? समजला?
सर नॅपे
बोला.
नॅपे मध्ये कोणता पोर्शन इरोड होते सर ते एक वेळ
वरचा जो जो अपर वाला पोर्शन असेल ना तो,
अच्छा ओके ठीक आहे.
म्हणजे हा वाला. हे बघ, हा वाला जो पोर्शन आहे अप्पर सरफेस, हा तो वाला इरोड होईल, कारण तो सगळ्यात जास्त वर आहे, म्हणजे सगळ्यात ससेप्टेबल आहे इरोजनला.
ओके सर.
ठीक है. Okay then, chalo. So this is it for today's class.